Hello everyone, I'm Harshika Narula from Grade 9C, the Lexicon International School, Kilani Nagar. Today I have a really interesting code with me. It is a stock price prediction. In this project, we will basically be taking a data set and we will be predicting how correct our AI model can accurately give the information, give the output of it. So first, we will import a few things. We have import pandas as PD, and we have a few sklearns, which are CountVectorizer, random forest classifier. CountVectorizer will basically be used for transform and fit. Random forest classifier is just the classifier I'm using. And then there is sklearn metrics, which we will be using that for classification report, accuracy score, and confusion matrix, using which we will be able to find out and predict how correct our AI model is. So first, we will have to get our, you can say, our file, which is stock sentiment. It is just a dataset I downloaded from Google. So we'll go to sample dataset and we will upload. Over here, I have my file over here. I will just open it. And then we will copy path and then read underscore CSV. We will paste the exact same path. The path can vary from different computers or different applications. So just make sure that you always get the correct path. Sometimes in platforms such as PyCharm, when you use pd.read underscore CSV, you can directly just write the name of the application and .csv. And then we have encoding, which is just you can say, which is just like encoding is just another argument that I'm using. It is not necessary, and if you don't put it, it will still work. But my stock sentiment dataset had a few problems, so to erase those problems, I had to use encoding. Next, I will do df.read once. We always do df.read whenever we're going to start coding because it helps us understand what is exactly there in our data frame and what we'll have to remove, what we'll have to change. So we also get to see if there are any empty places or any null values. So as you can see, there are no null values, but the names of the columns are like top 1, top 2, top 3. So in the later code, also be explaining how to remove these top 1, top 2, top 3, and instead we'll write 1, 2, 3, 4, which is way more easy to understand and use. And then we have date and label. Now, date and label we won't be needing to predict how correct our model is. So this model, what I'll just explain a little what this dataset contains. You can see that there are scorecard and a few comments. So these are basically comments of a company. Like you can see the news that has come in the company. Like maybe it was United rivals on the road to Rio. It is basically like small comments that were passed or the small news that came into the company. So all this news of a company is written down in the data set and they're categorized from top 1 to top 27, I guess, or yeah, 28. I'm not sure. So these are the rows that we have, including date and label. We will have, let's see how many we have. We have 27 columns, including the date and label. So we have 25 in total. And then we will split them into train and test. So usually, whenever we're splitting it into train and test, we usually split it through train test split, which is a function. But this time I opted for something different. Over here, what I've done is we have dates present. So I have categorized them from different dates. Like all the dates before 2015-0101, which is the 1st of January of 2015. All the dates, you can say like after it, we'll go into train because all the dates that are bigger than this will go into train, and all the dates that are less than 2014 December 31st will go in test. So I've not categorized it randomly. When we use train underscore test underscore split function, then we categorize it randomly. Over here, I have categorized it through the date. And then just to check if it has come correctly, I have printed the train ones. So you can see when I've printed the train, I have gotten this output, which looks nearly correct. It is just not in the table format anymore because I've categorized it differently. You can also convert it into a table format, but that's not necessary because later on we'll be adding more changes and it does not make sense to tabulize to make it tabular after every change that you make. So next we will be replacing. Like over here you can see in this line I have this punctuation. Now right now I know what it is, but the computer will not. We have commas, we have full stops, and we have space. Space is fine, but we have full stop, commas, double inverted commas, and we have quotes. We have so many more things. Now, these quotes, these punctuations usually confuse the data set, or you can say the model. So it acts as a barrier and it gives an error. So, from reframed from that happening, we will be using this replace function. So, for that, first, we will make a data. Now you can put any name of the variable because it is a random variable and data is equal to train.ilog. Over here we're basically defining all these, you can say data into the data variable. And then we will do data.replace. And now this is a really important function. What this function says is A to Z small and A to Z capital. If these letters are there, let them be. Now, if I don't put this caret sign, it will automatically remove all the A to Z's, small and capital, from the data. That is why caret sign basically acts as a not. So whatever is not A to Z small or A to Z capital, I will change it into space. So everywhere this punctuation is there, it will change it into space. And rejects is equal to true is a another argument which is not that important, and then we have in place is equal to true, which is very important. Whenever if you forget to put in place is equal to true, you will get an error in your whole code, because in place is equal to true basically means that the change you have made right now in this code section, it will be affected in all code sections below. Now, if you're not using Collab, you are using something like PyCharm or one compiler. This usually does not come as a problem. But in Collab, as we use different code sections to run different code parts, then in place is equal to true is very important. It comes in many functions. So we'll write in place is equal to true and we'll print the data. So now you can see if you I'll just give an example, top 22. Over here, you can see in top 22 there is a dash after flat. Now let's check if the dash is still here. So you can see the dash is replaced by a space. So this shows that it worked. Now it is very important to put the caret sign and you cannot put any other punctuation in this. Python is very case sensitive, so you need to make sure of that. And caret sign is really important. If you don't put caret sign, it will like basically change everything. It will take out all these letters and convert them into space, and you'll only be left with punctuation. Next, I told you we're going to change the name of the rows. It's not really important to change the name of the rows, but then maybe later sometime if you actually need to make a presentable tabular column, you'll need this. So for that, first I will take all the name of the rows, like which is top 1, top 2, top 3, into a list, and then I will make another list which will have the same exact numbers of the columns, and I will replace it. So in this code section, we are making the two lists. So first we'll make the first list which will contain all the top 1, top 2, top 3. So for that we'll write list 1 is equal to and I for I in range. Now over here, this is a for loop, normal for loop, and then I have written 25, whereas we have 27 columns in total. That is because we have removed the date and label. If you look at here properly, we do not have the date and label present. The date and label, which was there initially, this date and this label is removed. Though we still have this one and the number. So you can see this is the 3970 because our code consists of, let me just check. Our code consists of 3957 rows. So this is the second last row. Next, we will make another list which will contain the same numbers which are in the top 2, top 3, top 6. So it will be 0 to 24. So you can basically just write a list from 0 to 24. But if there are many columns, if there are many column headings, like from top 1 it is to top 59, you can't write all of them one by one. It will take too much time. So you can basically just write string I, which is I is over here for I, and for I in list 1. So we'll convert the I into new index, and then we'll print the new index. So you can see the old index, and this is the new index. And now we will put the new index instead of the old index in our data. So over here, first I have used the x in new index. So you can see over here now you can see 21 instead of top some number. So using this code, which is .str.lower, dot lower is nothing. It basically just converts the whole code into lower. Now, if you have capitals, that will also be a problem in the code. And now you'll ask, why couldn't we just convert it when we converted the punctuations? If we would have not put capital A to capital Z over here, then all the capital letters like this L, it would be converted into space. And then the word would make no sense. So that is why we basically just did dot lower function, dot string dot lower. So all the strings that are here will now be converted into lowercase. So that will be easy for the model to understand the word. So over here we have put the new index names, you can say, into the data. Next we have headlines.join. Now over here, the headlines, which are these lines, sold out, yet more things, these are all different headlines. Now I want all these headlines to be joined. In top 1, I need all the headlines together. In top 2, which is now maybe 1, all the headlines should be joined so that it is easy for the model to understand what all, like, what all comments or what all news came in that exact date or that exact time period, because we have categorized it according to dates. So for that, we will be making we will be joining all of these together. Now it is not easy to join all of these. You can put them all in a list, but after that you have to join them. And for joining we use ilock, which is another function. It is a very complex function, so we won't go into detail, but it is just like basically for x in data. Now in this line, this is a normal for loop. We have made an empty list, and then this is a normal for loop, and then we will do headlines.append. And now in this code, first this line will be run, which is the for loop for x in data ilock. And from r is basically r in range from 0 to 25, which is all the number of rows. And then we will be printing the headlines index 0. So the headlines index 0, why is headlines index 0 every time? Headlines index 0 is because all of this should come in the same index. This complete thing is one list segment. Whenever we write a list, we write L is equal to bracket and in quotes K, comma, U. So this space, we need all the headlines in that one space, because otherwise the model won't be able to understand properly. So for that we use this ilock function. So you can see now all these headlines are in the same line. Next, we will use CountVectorizer. Now CountVectorizer is basically, as I told you, used for fit and transform. So we'll just fit it into the data set. And now you can see we have the coordinates and the values. And then we will be using the classifier, random forest classifier. You can use any other classifier like decision tree classifier, but I find random forest classifier the best, so I usually use it. And then there is n underscore estimator is 200. So 200 is basically how random forest classifier works is it basically makes a forest. So first it makes trees and then it makes forests. It makes decisions according to branches. Like if this happens, then this will not happen. It basically categorizes it. So if I write 200, it will categorize it into 200 different categories. And then the criterion is entropy. There are many criterions, but for this code, entropy was the best. And then I'll be just fitting it into train data set. It will take a few minutes to load. Until then, I will just explain the later data. Now again, we'll be using iLock. So for that, first we'll make an empty list, which is for test underscore transform. Now we have the train data set. Now we'll be predicting the test data set and then we'll be checking if the test data set and test transform are the same. So first we'll make a test transform and then we'll be doing for row and range 0, comma len bracket test dot index. And then we'll be using append function to join all those test headlines. And then we'll be using the predict function from RFC. RFC is nothing but the random forest classifier. I have made its, you can say I've made its object as RFC. You can make it object as anything, but you'll need to remember that because you'll be needing to use the same object everywhere. And then you'll predict test and test underscore data set. So now we have predicted the test data set. So first we had our data, we converted it into train and test. And then after that, we converted the train data set. All the headlines we had, we converted it into one. And then now we used a test transform. And all the data you can say we got from test data set, we have converted into one, one headline. So now we need to check the accuracy score classification report and confusion matrix of both test data set and the predict we have gotten. Now, in this data set, what we had to predict was the label. Now, label is either 0 or it is either 1. Now, using all of these comments, we had printed if it is 0 or if it is 1. Now, it was based on a category. I'm not aware of that category. If it was just a category that the model had to find. And that is the whole purpose of the model. It will find out the category on the base it is categorized, and then it will try to categorize the test dataset that we've given it, and then we'll be checking how accurate information it has given. So let's see now. So now we have run it, and here we have the random forest classifier. It also gives us the information about what criterion we have used and the estimated number we have used. Next we'll be doing test underscore transform. And now we'll be finding the confusion matrix, classification report, and accuracy score. Now this is the confusion matrix. It is the most important matrix and it helps us to understand about the model in the best way possible. I will just show you an image on confusion matrix to help you understand it better. So this is the confusion matrix. This is the true positive, this is the false positive, this is the false negative, and this is the true negative. Now let's compare this with our output. This is the true positive, this is the false positive. Now what does false positive mean? True positive means that the value was 0 and the output that we got was also 0. True, which was this? It was false positive. False positive means that the output we got was 1, but the actual answer was 0. Now, this is false positive, sorry, false negative. False negative means the output was 0 and we got 1. And then there is true negative. True negative means that the output was negative, it was 0, and we also got 0. So 137 and 183 are the numbers that actually matter. So using this confusion matrix, we can see that the model actually predicted really nicely. Like from something around 400, it only had around 60 mistakes. It only predicted about 60 wrong, which was I when the output was 0, it printed 1, and so when the output was 1, it printed 0, which are the numbers of 49 and 9. And then I have printed the accuracy score. Score is 0.846, which is also really nice. So it is not overfitted, but it is also not underfitted. And then we have precision score, recall, which also show that it was really nice. So the model was perfectly trained and it gave us a really good output. So this was the stock price prediction. I hope it helped you, and don't forget to like and subscribe to my channel and enjoy coding. Thank you.